Okay, so before I actually get into doing it, let's talk a little bit about the idea behind this. Is that let's say um, I draw a rough sketch of this graph, and let's say this graph looks something like this. Okay, and so this is just a very rough sketch, but let's say you're looking for uh, the absolute maximums and minimums of this function from 0 to, let's say, here, 3. And so if you notice here, I mean, the idea is that since you're on a closed interval, so you only want to look at from 0 to 3. So it's kind of like you have this mental block, and it's only on 0 to 3. Now if you look here, the absolute maximum would be the absolute largest value, largest y value that your function can attain. Well, if you compare, notice that the absolute maximum happens right here at this endpoint, because at this endpoint it's lower. So this would be the absolute maximum. And that happens at an endpoint. Okay, but then the absolute minimum, well, that's obviously this one down here. And this happens at a local minimum. Now remember, local minimum. This is a spot where the derivative is equal to 0 because the slope of the tangent line is 0. And so that's the idea, is that you have to first find all the critical points, because that tells you where the local maximums or minimums are. And then you're going to compare those with the values of the function at the endpoints, because those could be maybe larger or smaller. And so that's the approach that we're going to take here. And that's the general idea. But you don't really need the graph to be able to answer these questions. You can just use calculus. And so let's do the first part. To find the critical points, we need to first find the derivative and then set it equal to 0 to solve it. And so the derivative of this one, it's pretty simple. It's just 3x squared minus 3. And remember, the critical points are where the derivative is either 0 or undefined. This is a polynomial, so it's not undefined anywhere. So we're just going to set it equal to 0 and solve it. And if we do that, we're going to get that x squared is equal to 1. And when we get the square root of both sides, we're going to have a positive and a negative. So these are the two critical points. X equals 1 and x equals negative 1. Okay, but notice that this guy, negative 1, is outside of my interval. And because here it starts from it only goes from 0 to 3. So this one I don't really have to check this time around. Okay, but I do have to check for the value at 1, so let's do that. So when x equals 1, y equals 1 cubed minus 3 times 1 plus 1. And so this is equal to 1 minus 3 is negative 2, plus 1 is negative 1. Okay, and then remember, our idea is that we compare this value with the endpoint. So we have to figure out the values of the function at the endpoint. So this is now the second step. So when x is equal to 0, y is equal to 0 cubed minus 3 times 0 plus 1 is equal to 1. And the last one, we're going to plug in 3. So when x is equal to 3, y is equal to 3 cubed minus 3 times 3 plus 1. So this is equal to 3 cubed, which is 27, minus 9, which is 18, plus 1 is 19. Okay, and so you look at these and you look for the smallest one out of all three of these. Well, that's this one. This would be your absolute minimum. And this would be our absolute maximum. And so we say that the absolute minimum occurs at the point 1, negative 1, and the absolute maximum occurs at 3, 19. And that's it.